Have you ever wondered what it would be like to step foot on Jupiter, the largest planet in our solar system? Jupiter, often seen as a bright twinkling star in our night sky, is in fact a behemoth of a planet. It's the heavyweight champion of our solar system, so massive that it could swallow over 1,000 Earths whole. Yes, you heard that right, over 1,000 Earths. But as much as we'd love to, we can't simply land a spaceship and step out onto Jupiter's surface for a leisurely spacewalk. Why, you ask? Well, that's because Jupiter is what we call a gas giant. Unlike Earth with its solid ground and breathable atmosphere, Jupiter is primarily composed of hydrogen and helium, the same elements that make up the Sun. This means that, instead of a solid surface, this colossal planet is made up of swirling, thick clouds of gas and dust. Imagine trying to walk in a never-ending storm of gas, not exactly a Sunday stroll in the park, now is it? One might think that being so big, Jupiter would have a solid core, much like Earth. But even that's a subject of much debate among scientists. Some suggest that deep within its gaseous outer layers, Jupiter may have a core made of rock and metal. However, this core is believed to be surrounded by a deep layer of metallic hydrogen, under such immense pressures that the hydrogen acts like an electrical conductor. And if that's not enough to dissuade any would-be space explorers, Jupiter's extreme weather conditions, with storms larger than Earth and winds faster than the speed of sound, make it a rather inhospitable place. So, if we can't step foot on Jupiter, what makes this gas giant so terrifying? Well, sit tight and prepare to embark on a journey of cosmic proportions, as we unravel the curious and somewhat terrifying case of Jupiter. Imagine a storm so powerful it's been raging for centuries. Welcome to the tumultuous world of Jupiter, home to the largest and most fierce storm in our solar system, the Great Red Spot. This isn't just any ordinary storm, it's a swirling, whirling, colossal tempest that's been ongoing for at least 300 years. Yes, you heard that right, 3 centuries of non-stop, unabated storming. The Great Red Spot is truly a testament to Jupiter's stormy temperament. It's so large that about 2 to 3 Earth-sized planets could fit comfortably within its boundaries. Now just take a moment to ponder that. The largest storm ever recorded on Earth, Typhoon Tip, was about 2,000 kilometers in diameter. But the Great Red Spot, it's a staggering 22,000 kilometers wide. That's over 10 times larger. And it's not just the size that's astounding, the winds within this storm are ferocious, reaching speeds of up to 430 kilometers per hour. That's more than twice the speed of the most intense hurricanes on our planet. But what powers such a monstrous storm? It's all about heat, or rather the lack of it. Jupiter's outer atmosphere is extremely cold, but as you descend it gets hotter and hotter. This heat differential creates immense atmospheric turbulence, fueling the storm and keeping it alive for centuries. Yet, despite its fiery intensity, the Great Red Spot is slowly shrinking. Over the past 150 years, it has decreased to almost half of its original size. But don't be fooled. Even as it shrinks, the storm remains a formidable force, a vivid reminder of the power and mystery of the cosmos. The Great Red Spot is a testament to Jupiter's stormy nature. It's a maelstrom of unimaginable proportions, a hurricane that puts our earthly storms to shame. And the most terrifying part? But the Great Red Spot is not the only terrifying feature of Jupiter. Jupiter is a planet of extremes, and there's much more to its story than this one storm. If you thought hurricanes on Earth were bad, wait till you hear about Jupiter's winds. Jupiter, the largest planet in our solar system, is a world where extreme is the norm. One of the most stunning features of this gas giant is its winds, which defy everything we know about meteorology on Earth. These aren't your average gusts of wind. They are colossal, relentless, and incredibly fast. Imagine a hurricane on Earth, with winds tearing through at 100, maybe 200 miles per hour. Now, let's take that concept and multiply it by 2. Yes, you heard that right. Jupiter's winds can reach up to a staggering 384 miles per hour. That's nearly twice as fast as the strongest hurricane ever recorded on Earth. These winds are part of what shapes Jupiter's unique atmosphere. They whip through the planet's clouds, creating the beautiful, intricate patterns we see when we look at Jupiter from afar. The stripes and swirls we observe are actually bands of high-speed winds moving in different directions. But these winds aren't just for show. They play a vital role in Jupiter's climate and weather systems, driving storms that can last for centuries. Like the Great Red Spot, a tempest bigger than Earth itself, which has been raging on Jupiter for at least 300 years. What's even more fascinating is that these winds persist, without a solid surface to generate friction. Unlike on Earth, where winds are slowed down by mountains, trees, and buildings, Jupiter's winds have nothing to stop them. They just keep going and going, making Jupiter the windiest place in the solar system. So, next time you're caught in a gust of wind, remember, even our wildest weather is tame compared to the extreme winds on Jupiter. It's a sobering reminder of how gentle our own planet really is, and how truly wild the universe can be. And these winds are just the start of Jupiter's terrifying climate. Imagine a world so cold, it makes our coldest winters seem like a warm summer day. Welcome to Jupiter, the frigid giant of our solar system. This behemoth planet, known for its swirling storms and colossal size, also holds the chilling record for some of the coldest temperatures in our solar neighborhood. Its outer atmosphere, a tumultuous blend of hydrogen and helium, dips to a staggering negative 145 degrees Celsius, or negative 234 degrees Fahrenheit. To put this into perspective, the coldest temperature ever recorded on Earth was at a research station in Antarctica, plummeting to negative 89 degrees Celsius, or negative 128 degrees Fahrenheit. Jupiter's outer atmosphere is nearly twice as cold. Now you may be wondering how this is possible. After all, Jupiter is not the furthest planet from the Sun. However, the size of Jupiter and its distance from the Sun mean that the heat it receives is spread out over a large area, and much of it is reflected back into space. Furthermore, the planet's thick clouds reflect sunlight away, preventing it from warming the surface. But it's not just the cold that makes Jupiter's atmosphere so inhospitable. The lack of a solid surface means that you would simply fall into the planet if you were to somehow land there. And as you descended, the temperature would rise significantly due to the immense pressure, creating a harsh and inhospitable environment of extreme cold and extreme heat. So, as you bundle up for the winter, take a moment to appreciate the relatively mild climate of our home planet. Earth's coldest places are a tropical paradise compared to the frigid outer space giant that is Jupiter. And the cold is not the only extreme condition you'd have to face on Jupiter. Imagine an environment so intense, it could crush you in an instant. Welcome to Jupiter, a planet that could give new meaning to the term under pressure. Jupiter's atmosphere is an enormous pressure cooker, with levels far beyond anything we experience on Earth. Let's put things into perspective. The pressure we feel at sea level on Earth is about 1 bar. It's comfortable, it's familiar, and it's just right for life as we know it. But if you were to venture into the deepest parts of our oceans, you'd experience pressures about 1,000 times greater. Still, that's nothing compared to the crushing pressure on Jupiter. Jupiter's atmosphere is composed mostly of hydrogen and helium, similar to the Sun. As you descend into the planet's atmosphere, the pressure and temperature increase dramatically. At the point where the atmosphere transitions into the planet's interior, the pressure is estimated to be a staggering 3 million times the atmospheric pressure at sea level on Earth. That's as if you had 1,000,000 Earths pressing down on you. This pressure is so immense that it squeezes hydrogen into a state rarely seen on Earth, metallic hydrogen. This exotic form of hydrogen, which acts like an electrically conducting metal, is believed to be the source of Jupiter's intense magnetic field. Now, if a spacecraft were to venture into Jupiter's atmosphere, it would be crushed, melted, and vaporized long before it could explore the depths of this gaseous giant. It's a testament to the planet's unforgiving nature, and a stark reminder of the challenges that await future explorers. Intriguingly, it's this same crushing pressure combined with extreme temperatures that makes Jupiter a fascinating subject for scientists. The planet's conditions could give us clues about the early solar system and the processes that govern the universe. But pressure and temperature extremes are not the only threats you'd face on Jupiter. Imagine being in a place where deadly radiation is part of everyday life. Jupiter's environment is not just extreme, it's deadly. The gas giant is surrounded by an intense radiation belt, a force field of charged particles that are trapped by Jupiter's strong magnetic field. This radiation is thousands of times more potent than what we are exposed to here on Earth. On our home planet, we're protected by Earth's magnetic field, which deflects most of the sun's harmful radiation. We're exposed to a certain level of radiation daily, but it's usually harmless. However, if you were to step foot on Jupiter, the situation would be drastically different. Jupiter's radiation belts are so powerful that they can strip away the surface of its moons, leaving them barren and lifeless. These belts are made up of high-energy electrons, protons, and ions, racing around the planet at nearly the speed of light. And they're not just on the surface, they extend out to about 6 million miles from the planet. To give you a sense of the radiation level on Jupiter, let's consider a comparison. The radiation dose we receive from a dental X-ray is about 5 microsieverts. The radiation dose in Jupiter's radiation belt? It can reach up to 20 million sieverts per day. That's enough to fry any electronics in minutes and lethal to humans in seconds. Even our most robust spacecraft have to be built with special materials and designs to withstand the onslaught of this radiation. NASA's Juno spacecraft, for instance, is armored with a radiation vault to protect its delicate electronics from Jupiter's deadly radiation. So, Jupiter is a harsh and deadly world, far from the hospitable conditions we enjoy on Earth. Its radiation belts are a testament to the planet's raw and untamed power, a power that could easily obliterate us if we were to venture too close. So, given all these terrifying facts, why do we continue to study Jupiter? Despite its terrifying conditions, Jupiter holds a certain allure for scientists and space enthusiasts alike. There's a certain charm to the colossal gas giant, a pull that extends beyond its immense gravitational force. It's not just the mesmerizing swirls of its atmosphere, or the hypnotic dance of its 67 moons. Jupiter, in all its terrifying grandeur, offers far more than a spellbinding spectacle. For one, it's a treasure trove of scientific mysteries, a celestial puzzle waiting to be solved. Its immense size and complex structure challenge our understanding of planetary formation. How did such a behemoth come to be? What processes are at play beneath those swirling clouds? These questions drive scientists to probe deeper into Jupiter's secrets, pushing the boundaries of human knowledge and technology. More than just a scientific curiosity, Jupiter may hold the key to understanding our own place in the cosmos. As the largest planet in the solar system, it has a profound influence on its celestial neighbors. Its gravitational pull shapes the paths of asteroids and comets, acting as a sort of cosmic shield that protects the inner planets from catastrophic impacts. By studying Jupiter, we gain insights into the complex dynamics of our solar system and our own planet's history. But perhaps the most tantalizing possibility of all is the prospect of life. Beneath the turbulent clouds of Jupiter's moon Europa lies a vast ocean that could potentially harbor extraterrestrial life. This possibility has fueled countless missions and sparked the imaginations of scientists and dreamers alike. The thought that we might not be alone in the universe, that life could exist in such an extreme environment, is a potent lure. So, Jupiter, as terrifying as it is, continues to captivate us with its mysteries. Despite its daunting storms, bone-crushing pressures, and lethal radiation, we remain spellbound by the gas giant, drawn by the allure of its enigmatic presence and the potential discoveries that lie hidden within its depths. Jupiter, a planet of storms, extreme winds, frigid temperatures, crushing pressure, and deadly radiation. As we journey back through the tempestuous features of this gas giant, we are reminded of the magnitude and ferocity of its stormy nature. Jupiter, the stormy giant, has been home to the Great Red Spot, a storm larger than Earth that has raged on for centuries, a testament to its unrelenting, turbulent atmosphere. Let's not forget the extreme winds, reaching speeds of more than 300 miles per hour, that whip around this colossal planet, making our fiercest hurricanes seem like a gentle breeze. These winds contribute to the beautiful, banded appearance of Jupiter, but they also create an environment that would be inhospitable to life as we know it. Then there's the frigid nature of this outer space giant. Despite its distance from the sun, Jupiter radiates more heat than it receives. But don't be fooled. With temperatures plummeting to minus 200 degrees Fahrenheit in its upper atmosphere, it's anything but warm and welcoming. Beneath these swirling clouds, there's an unimaginable pressure, crushing everything in its path. Here, the pressure is so extreme that it creates metallic hydrogen, a substance found nowhere else in the universe. And if all these weren't enough, we also have the deadly radiation. Jupiter's magnetic field traps high-energy particles, creating intense radiation belts that could easily fry a spacecraft. Yet despite these terrifying aspects, we're drawn to the allure of Jupiter, a planet that continues to fascinate us with its size, its moons, and its mysteries. It's a testament to our curiosity, our thirst for knowledge and understanding of the universe we inhabit. And so, we continue our journey, exploring the terrifying yet fascinating world of Jupiter, the giant of our solar system.